7.3 exponential equations. Okay, so this is an interesting section because it deals with what I feel are very popular formulas that you run into, even if you're not a mathematician. One of them is half-life, which I'm assuming you guys have done in chemistry at least once or twice, half-life, or biology maybe, okay, when you're studying the age of things. Population growth and decay, you've definitely dealt with that in math, maybe biology as well. Do you guys study population models? Watch stuff grow, and do they have equations? I never took Bio 30.
I don't know, we just did math.
Yeah, okay, well, they're here. Okay. This other formula, A equals P times 1 plus blah, 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 blah. That's like my favorite. I think I'd say it's my favorite formula. My favorite, like, day-to-day formula. It is a formula that you can use whether or not you're a math bent person after high school. Because when I'm trying to figure out how to pay off a loan, I use this formula to help me understand how the interest is going to affect my loan. When I try to figure out how much an investment is going to be worth after a certain period of time, this formula I use quite a bit. So I hope by the end that at least you have some appreciation for that guy, because it is very useful. I just want to make some comments on some of those formulas because you will need to use a few of them in your assignments. Okay. For the half-life formula, we have n equals n naught 1 over 2 to the power of t over h. Okay, and I just want to identify some of these variables because it's important that you know what they are, especially when you need to use them in your assignment. This n right here, what would that be?
That's the amount, the mass.
Yeah, it's the mass of your specimen after t hours. Okay, I was going to put a number, but mass makes a little more sense. So this is mass after t hours, after so many hours. Okay, n naught, what would that be?
Initial mass.
Yeah, the initial mass. The 1 over 2 is the rate, because it's half-life. T up top is just your time, how much time has progressed. And H is the half-life of whatever material you're talking about. Okay? So if you don't know what those variables mean, maybe just make a note of it on your papers, because you will need to use those in a bit. The population growth decay model, P equals P naught times R to the T, follows a similar structure from the half-life model. What would P mean? Just P by itself, this guy.
The final number.
Okay, or population, again, after T hours, right? So if I was studying a herd of elk and that herd doubled every 7 years, okay, P would tell me how many elk there are after so many years of studying that population. P naught is the initial population. Okay, that subscript 0, which you say naught, usually indicates some kind of initial condition. And then the rest should be pretty intuitive. R is the rate of growth or decay. T is how long or how much time has passed. Good? And then this last one looks a little bit different than the other guys, but still follows a similar model. The investments or loan growth and decline formula. A equals P times 1 plus I over C to the power of n times C. Okay. So I'll list the variables here. A is what you call the accumulated amount. So in terms of investments speak, that's how much money you have after a certain period of time. after the investment's been growing for like 2-3 years. That's the accumulated amount. It's how much it's worth after a certain period of time. P is your principal. That's how much you put into the investment. Okay, so if I give the bank $1,000 to grow at, 3% or something like that, then that would be P. Okay, the amount of money that I start my investment at. I is the interest rate. That should be pretty obvious. I'll explain C in a moment. N is a number of years that your investment has been growing. And C is something called a compounding period. Do you guys know what compound interest is?
Yeah.
You do? Yeah. Do you know how compounding periods work?
Not really.
Go in this in business class.
Okay. Just kind of file it away for a moment. I'll tell you what a compounding period is when we get to an example about it. Okay? But just for the sake of explaining the formula, C is your compounding period. I'll tell you what it means in the third example, I think it is. Okay? So, these are examples of some equations, some exponential equations that people use, not just mathematicians, but biologists, economists, economists, that's how you say it, yeah. Scientists, nerdy people who like tracking their money. Who does that? Psh. Just put everything on the credit card. Who cares? No, it's bad advice.